each draw from the urn, if we replace the ball afterwards, is going to be independent of the next draw. And so, like, you may not have exactly learned that law, but you know, it would be something that I could see the professor thinking is easily implied by what you do know. And maybe you guys were taught about independence. But so if you draw 500 times, what's the probability? And the probability of drawing a red ball is 3 out of 10. Then what's the probability of drawing a red ball 500,000 times out of a million? Well, not out of a million. Sorry, just drawing it 500,000 times in a row. Just multiplying 3 out of 10 times 3 out of 10 times 3 out of 10 times 3 out of 10, 500,000 times. Okay. All right. And so it's the case that, let's see. So even, sure. Oh, sorry. That should be a, thank you. Yeah, it should be a 2 to the 500,000. The lack of formatting I mentioned earlier is, yeah, why that happened. Sorry about that. So in this case, this is just about drawing an implication from Bayes' rule and showing that even in large samples, as long as we have exact probabilities, we're going to have the same results from large samples as we do of, you know, just a couple of draws, as long as the probabilities are exact. Okay. Okay, so we've also been talking about heuristics and biases. This is part of quasi-Bayesian analysis, which is why we studied it along with Bayes' rule. So essentially, statistical inferences here are driven by Bayes' rule, but with psychological phenomena thrown in. Okay, so Bayes rate neglect is going to be one example. Instead of knowing the true underlying probability of an event that you're trying to infer, you believe those possibles are equally likely. When we have Bayes rate neglect problems, you then use the believed probability or perceived probability of the person with Bayes rate neglect in place of the one that occurs in real life every time it shows up in Bayes' rule or any other formula. Okay, so let's do that with urns. So suppose urn 1, drawing a ball from, let me see, the probability of A and B were, so the probability of drawing a red ball, I believe that was, drawing a red ball from an unknown urn. Okay, here we go. So the probability of drawing a ball from either urn 1 or urn 2, whereas it was closer together in the problem I just skimmed over quickly. Suppose the probability of drawing just a random ball from urn 1 is much less likely than urn 2, so 10% versus 90%. However, in probability, in truth, it's the case that it's, let's see, that it's closer, that it's 3 tenths versus 6 tenths. And so we want to make sure that if the incorrect calculation here, the Bayes rate neglect probability is PA equals 10%, that we plug that probability into the formula instead of the true probability. Let's see. But with Bayes rate neglect, and I think in this class we've been assuming that each urn is equally likely. I just flipped it around. Darn it. So the true probability is 10%. If the true probability of drawing a ball from urn 1 is 10%, the true probability of drawing a ball from urn 2 is 90%. Sorry, those are going to be the true probabilities. However, with Bayes rate neglect, what we assume in this class, I believe, is that drawing from each urn is equally likely versus just having Bayes rate neglect. You can have any difference, but I think it's simplified in this class to where you assume that each possibility is equally likely versus just closer together than farther apart. So we need to make sure we plug PA equals 50% and PB equals 50% into any Bayesian calculation or any calculation of probability that we use. Okay. Bayes rate neglect is also one thing underlying the conjunction fallacy, believing that one thing happening is less likely than two things happening simultaneously. I won't go through the proof, but okay, so this is an example that I know I gave in section. So suppose we observe that someone is liberal. So among bank tellers, if we know that 25% are liberal in reality, but among feminist bank tellers, 75% are bank tellers. Among feminists, yes. 75% are bank tellers, and 25% of people overall are liberal. If there's Bayes rate neglect, we act like feminist bank tellers, and bank tellers in general are equally likely. So here, which is the marginal probability in this sentence? Bank tellers or feminist bank tellers? Yeah, just plain old bank tellers. Whereas feminist bank tellers is a joint probability. Okay. So in this case, instead of perceiving the probability of, we would perceive the marginal and the joint probability as being equal. So the inferred probability of a liberal bank teller, we would say is 0.25, and the inferred probability of a feminist bank teller and liberal is going to be 0.75. However, the first must be, in fact, at least weakly larger than the second. And why is that? Anyone read the section solutions? Oh, sorry. Yeah. So for instance, like with red and blue dots, if I have red dots, the probability that I have red and blue dots has to be smaller than the probability that I have just red dots, because blue dots is an additional characteristic. So for here, being both a bank teller and liberal the probability of being a feminist bank teller and liberal is going to be a subset of bank teller and liberal because you're adding an extra characteristic to the probability you're trying to calculate. This is why I wish we could require probability, but all right. But yeah, just remember Bayes formula, and I'll put the proof from my section solutions here too. Sorry, this is supposed to be a joint probability. So the probability that a feminist bank teller is also liberal. Yeah. Yeah, sorry, with the formatting sometimes yeah. Okay. Oh, okay. So we're out of time, so I didn't get to the problem solving, but it's okay. So most of them are from prior exams. So whatever the professor doesn't post as the solutions, I'll post myself. But he said he's going to post the exam solutions. So. Oh, yes, so that's what I was saying. So a lot of them are from prior exams. So I know some of them aren't. So you won't see. So I will post whatever's probably not going to be posted, and then I'll make sure everything is eventually posted. Yeah. Oh, I'm sorry. Okay. Can you yell? Oh, for fall 2013. So I have to ask him on that. I ran the worksheet by him, so I know I can post the solutions to the worksheet. But I'm surprised he didn't post. Yeah, I was under the impression that he was going to post all the solutions to all the finals. So I'll check on that. So I have a meeting with my dissertation advisor tomorrow morning. So it'll definitely be at least a solid week in advance. Yeah, and there's also a study guide online as well. So if you're, so not today. I will definitely post the slides. Yeah, at least a week before the final. So by Friday for sure. So my meeting is at 10. So I think I'm gonna have to do 8 to 10. Yeah. I'm guessing nobody is going to be holding their office hours this week, or very few people are going to hold them. So I'm going to post wherever I am on the door. Because I called the office and they said that they didn't have the office hour booklet, which is yeah. Oh yeah. No, I'll definitely email. Yeah. Oh yes. Yes. If you're my student, please come get old things. Although I don't have problem set 6 ready yet, and no midterm 2 regrades yet either.